You visit a website. A pop-up asks you to accept all cookies and you click No. In the back of your mind, that means they cannot track you. But they still can. The site recognizes your device as the same one that visited before, and it never planted a single cookie to do it. So how does it know who you are? Well, to start things off, every time your browser loads a page, it sends information about itself. Some of it is obvious, like your IP address, which browser you're running, and the language you have set. But a site can also run small scripts that ask your browser far more specific questions. What is your screen resolution? What time zone is your device set to? How many CPU cores does it have? Which fonts are installed? How does your graphics card render a particular image? On its own, none of this points to you. A screen resolution of 1920 by 1080 is shared by tens of millions of people. So is the Eastern time zone. But layer the resolution together with the time zone, the language, the installed fonts, the graphics output, the audio behavior, and 20 more attributes, and that combination gets specific enough to pick one device out of a crowd. A fingerprinting script gathers all of it as the page loads, runs it through a hash, and turns it into a single identifier. No cookie is stored on your machine. The identifier sits on the server. The strongest signals come from two browser features almost nobody thinks of as privacy risks. The first is the Canvas API, a feature built to let websites draw graphics. A fingerprinting script tells your browser to draw a hidden image, usually a line of text over some shapes, then reads back the exact pixels. The way that image renders depends on your GPU, your operating system, your browser version, and your font rendering engine. Two machines running the same browser on different hardware produce slightly different pixels. The Tor project calls Canvas the single largest fingerprinting threat browsers face today. The second is WebGL, the API used for 3D graphics. A script can query it for your GPU vendor and renderer, often pulling back the exact model of your graphics card. That alone is distinctive. Paired with Canvas output, it becomes very hard to confuse with anyone else. A typical script collects somewhere between 50 and 200 of these data points in the time a page takes to load, and you never see it happen. Another surprising signal is the set of fonts on your device. Your machine accumulates fonts from everything you have ever installed. A design program adds its own. So does Office software, the occasional game, a developer toolkit. The exact set you end up with depends on your history, which makes it fairly distinctive. Scripts cannot read your font list directly, so they measure it indirectly. The script renders a word in a target font and checks how wide it comes out. A width that matches the fallback font means the target probably is not installed. A different width means it probably is. Repeat that across hundreds of fonts and you reconstruct most of what is on the device. Research puts the average Windows system at more than 200 installed fonts. The variation between users is wide enough that the font set alone carries real identifying power. What makes fingerprinting so hard to escape is how stable it is. Cookies get deleted. An IP address changes the moment you switch networks. The fingerprint mostly stays put. None of the usual privacy steps reach the things fingerprinting reads. Your hardware and your installed fonts are exactly the same after you clear your history, open a private window, or route through a VPN. A study from InterIA found that 89% of browser fingerprints could still be uniquely identified after 90 days, with no deliberate change from the user. This is also why some popular privacy tools fall short. A VPN hides your IP address, which is one data point, your Canvas output, your WebGL renderer, your fonts, your audio behavior, and your time zone still match the device underneath. A site that fingerprinted you while you were on a VPN can recognize you later when you connect directly. Private browsing does even less here. It keeps cookies from being saved, but fingerprinting never relied on anything saved to your device in the first place, so there is nothing for private mode to clear away. More than a quarter of the top 10,000 sites were running some form of fingerprinting by 2021, up sharply from a few years before. Advertisers use it to follow people across sites for ad targeting. For fraud teams, it flags the same device sitting behind several accounts, and banks fold it into identity checks as an extra signal. Regulators treat it the same way they treat cookies. Under EU rules, reading or storing this kind of device information counts as personal data processing and requires explicit consent, just like a tracking cookie. Most sites that run fingerprinting scripts never disclose it clearly, and plenty of site owners have no idea their analytics or ad scripts are doing it at all. Defenses exist, with trade-offs. The Tor browser is built so that every user looks the same, by standardizing canvas output, switching off certain APIs, and normalizing the attributes a site can read. The cost is that Tor looks and behaves noticeably different from a normal browser, which is itself a signal. Even so, fewer than 5% of Tor browser users produce a unique fingerprint, far better than the general population. For everyone else, Firefox on strict privacy settings, along with an extension like Canvas Blocker, adds noise to Canvas and WebGL output. The catch is that noise can backfire. If your noise pattern differs from other people using the same tool, it can make you more distinctive instead of less. To summarize everything, the reason browser fingerprinting works is that your device is not generic. Every mix of hardware, software, fonts, and settings produces slightly different output when a browser answers certain questions, and that combination points back to you. Clearing cookies does nothing because cookies were never part of it. A private window has nothing to wipe since the technique never writes to your device. And a VPN only swaps your IP, which is one signal among dozens. None of this is secret in a technical sense. The browser AP is involved are standard and well documented. What most people miss is that the ordinary information a browser hands over during a normal page load can be assembled into an identifier, without their knowledge and without leaving a trace on their side. You can land on a site you have never logged into, with a brand new browser profile, behind a VPN, with cookies switched off. If that site is fingerprinting, it has very likely seen your device already.